Hello. Okay. All right. So who do I have first here? Nice. Let me get the eight of this there. Oh, I think I got something right here bothering me. Can I number you guys? Student number 16. Who be that? That's you, right? Isn't that him? Huh? All right. So Grant, you moved from, what are you now, 11 instead of 10? Yeah. But then now there's no 10. Okay. Grant, you made the video. All right. Okay. Brian, I guess I'll make Brian make the video. What do I input first on this first one here? You are correct. All right. I don't know. I don't want to take credit, but maybe it is this new approach that I've done that's really helped the grafting for you guys. Really focusing on what the important points are and then getting a good picture. What ends up happening? Negative 3 plus 3 is 0. What's 3 to the 0 power? Negative 1, right? And then negative 1 minus 4. Yeah, and I wasn't saying you were wrong. 3 to the 0 is 1, but then you snap a negative on it. Order of operations. Negative 3 comma 1, 2, 3, 4, 5. And then at this point, you should analyze, okay, wait a minute. All right, what's that minus 4 do? What does it do to the graph? Brings it down 4, and you should have memorized that there is a horizontal asymptote, not at y equals 0 now, at y equals 4, negative, sorry. And then, oh, why is that point on the other side? Oh, okay, that's a negative in front, which flips it over the x-axis. So it flipped it on the other side of that asymptote. So we get all that information from that one input-output, I would hope. And you can prove it by 2 more points. And actually, negative 2 is the easy one. What's negative 2 plus 3, Brian? 1. What's 3 to the first? 3. Negative. Negative 3 minus 4? Negative 7. And then there's where we get the negative 2, negative 7. That should be enough. This is what the graph is doing, and it's coming from that side like that. I'll prove that last point. I'll do it. Negative 4 plus 3 is negative 1. This is making me sad. All day long, this has been wrong. What's 3 to the negative first? Those that know answer. 1/3. Why are we not getting that still? Why do we not know the negative exponent rule as a fraction? Negative 1/3 minus 4 is negative 4 1/3. I don't get it. I don't get how we don't get some of these things and they're not just clicking after we mention it over and over again. Okay, stop complaining. All right. And then I guess some other stuff I could answer. Hey, student number 1. Nice. Vanessa, we can do limits. Domain and range we could do too. I'll do that real quick. Domain is all real numbers. Range is actually negative infinity up to negative 4, right? Not including negative 4. But what's that limit? As x goes to infinity, what's the limit of f of x? Okay, so as x goes to infinity, where does y go? Negative infinity. Once we do the hands, it makes it easy. And then as x goes to infinity negative, what's the limit of f of x? That's the asymptote, and that's good. Good answers, done. And then I verbalized the domain and range. Should be okay on that one. All right, who gets the input-output on this one? Student number 9. That is Matt. Okay, so Matt had this cut off, but now that you see it, instantaneously, what do you think about inputting? You do put 2, but what's the problem with plugging in 2? But this is why we plug it in. What's the problem with that? It doesn't equal 0. It does equal 0 there, yes, okay, but what's log of 0? What's that equal? That is not possible. But what is this here then? And this is what I think has been helpful. I think more so than any other year, the logarithm graphs were really good. I think that was the best I've ever seen a group of students graph the logarithms. They located that vertical asymptote because of maybe that approach. And then one more thing, Matt. Actually, we're going to do 2 more, but I'm going to plug in 3. Wrong. Can I plug in 3, Matt? Yes or no? No, I made an accidental mistake there. That creates a negative. It should have been 1 that I plug in. Oh, and then this is why. I do want to cover this as far as transformations are concerned. This is where the 2 right came into play. If I rewrite this like this, and then obviously 3 up. But there's a y-axis reflection. That's why we're going to be on the left side of this. Okay, so now let's go back to the original. 2 minus 1 is what? By the way, what's the base on this logarithm? 10. So you don't hear his answers, which are all awesome. Base 10 is what the base is. 10 to what power equals 1? What's 0 plus 3? And that's it. Answering all the questions like a math ninja. We can do one more point. Those that were working, which was, I think, everyone were awesome on Friday with that worksheet. We had an LN graph, which, how do I get another coordinate when E doesn't go with other numbers? You kind of can't. This one you can, though. I can, Matt, plug in -8. Because what's 2 minus -8? Oh, 10. 10 to what power equals 10? 1 plus 3 is what? Well, we just outputted there. 1, 2, 3, 4. And that one I can. And then this one does show that I have this shape right here. Probably should write domain and range down. I'm getting lazy though. Domain is actually affected. It's negative infinity to that 2, that asymptote. The range is all real numbers. There is no horizontal asymptote holding anything down. Good job. Awesome so far, everybody. This is why I enjoy doing this. And even if you do struggle, we can help you through it. Lindsay, I think you did move to 18, didn't you, when you moved up in that seat? Nice. Okay, so limits that I could ask. Limit of f of x, I can't ask as x goes to infinity. There is no graph on that side. I can only ask that one first. What's the answer, Lindsay? As x goes to negative infinity. It is infinity. And then the other special limit is the limit of f of x as x approaches the asymptote. From the left or the right, Lindsay, do I care about? Only from the left, which is to negative. Do you know the answer? It is negative infinity. X finger, Y finger is, sorry, I did not actually write. Oh, I did write negative. Okay. I thought I forgot to write negative. As I plug in X's here, the Y's go down to here as we approach that border. So remember, I've lamented how many people got all of those limit questions wrong in the Chapter 2 test. I just don't know what I can do for you. All right, remember, I don't go over those tests with you, tests. I do go over quizzes, and we do have to spend time on that last 3-1-3-3 quiz to get that back before our test Friday. But not tests, use Compass. And not enough people are you. Today would have been a perfect day. I got a lot of my bums in the regular Compass class, they never leave. They never do anything, and they're sitting around their phone for 35 minutes. It's like Compass is a big waste of time thing. Well, use it wisely. If you have days that you have nothing going on, sign yourself up. All right. Hopefully they get rid of that 24-hour thing. I think that's in the works that you'll be able to sign up at 8 in the morning for today, like, that actual day. I think they are getting that fixed up. Okay, anyway, done with that. This is actually 3.5 and 3.6, and I think my calendar coincides with this. I think I said 2 through 10 even, though. I don't know. But don't write that assignment down. It's not mathematics of science in 3.5. It's a new thing called Newton's Law of Cooling. And I don't know if I used the book for anything other than just these 3 questions from that section 3.5. Right? You really got nothing. Tomorrow's the last new lesson. Tomorrow's Tuesday. Your test is Friday. There's no complaining about getting ready. And there really shouldn't be any complaining about this. So go ahead and write this down. This is one of the cooler, no pun intended there, cooler formulas here that pertain to maybe anyone ever watch CSI shows? Huh? Like shows where there's a dead body, and then they ask, what do you think the time of death was? And they got someone working on that. Not saying it's exactly this formula, but it's along the same realm. When a body dies, and if it dies and it's out in the snow, then of course the temperature starts, coalescing to the temperature that's surrounding it. So that does affect what the temperature is, and then through math we can figure out how long that body, how long it's passed away, like what the time rate is. So that's what this is. It's called Newton's Law of Cooling for any objects. Of course, I'm sure mass matters. I think in those shows, CSI is coming back. The one from Las Vegas. We used to watch that one with Grissom was his name. if you know that show. That was back in the 2000, I think that show came out, before you were even born. But I remember watching that show diligently, and they'd actually get the temperature of the liver, because I think it was more surrounded and it had more of a constant rate, so you could really tell, almost to exact precision. But anyway, that's what this is. So what do you think the big T stands for? 3, 2, 1, go. Not time. Temperature. What's the little t, though? Time. So this first thing is temperature as a function of time. That's T of T. And then equals. Well, this should be easy. What's T sub 0 equal before you even look at anything? 3, 2, 1, go. Initial temperature. For a body, it's 98.6 on the norm, unless they had a fever or something. COVID, if you will. And then T sub M. That's a weird one. And that's just, they call that the temperature of the medium surrounding the object. All right, so that's what the T sub M stands for. I guess that's what medium means. I don't really know. It seems weird. Definitely a different definition of that word. And then K, I wish was R, but they use K. Sometimes they do use K as a variable for rates. K is the rate, and notice the negative is built in. Just remember this, because when I calculate something, I gotta reinsert that negative. So the temperature should go down, but we actually could use this for temperatures going up too. I could place, I could do a reversal on the next question I'm gonna have. I pull an egg out of the fridge and I put it in boiling water. Well, that temperature is gonna rise. That's a rising rate for a temperature. So that's another thing you could do. You could use this both ways. It could be Newton's law of cooling or Newton's law of heating. It kind of is true. And I don't want you to freak out over this. It's just PEMDAS, man. I don't understand why people have such a hard time with this when it's really not that bad. The reason they do is the math that they came in with. Their ability to solve equations effectively without making numerical simple mistakes. It really is true. All right, so K is a rate at which the temperature changes. Okay, now I want you to focus on this question real quick. And then I'm going to tell you that this question is identical, very identical in the book. It's actually a cryptic question where it sneakily inserts 2 different questions in here. And I really want you to harp on that when you're doing your homework. And for the love of dog, when you're doing your homework, look at the notes. You got too many people that don't do that, and then too many people that wait 3 days, like over the weekend, and then look at their homework, and you're not using your notes as a guide. So being real specific, how this question is kind of weird. This first sentence actually gives me a situation that is solvable, and it is completely different than the second sentence. So, a hard-boiled egg at temperature 96 degrees Celsius. By the way, what is boiling water? What temperature is that in Celsius? It's very close to this. 3, 2, 1, go. 100. So we're getting it close to that boiling level. The egg almost achieves the water's level of boiling. Then this is usually what you do with a hard-boiled egg. You put it in cold water. So you place it in 16 degrees. 4 minutes later, you measure the temperature to be 45 degrees Celsius. Stop! That is enough information to plug in to find a K value, to find the rate. And that's what we're going to do first. We're ready. Then use Newton's law of cooling to determine when the egg will be 20 degrees. That's a second separate question, which we're going to use this K that we got in order to solve the blue. So there's 2 parts to this, right? And as a person that reads and can read and understand, hopefully you get that. But first of all, I don't know if you would, and I remember back in the day this caused a problem the way they worded these. Okay, so here we go. Oh yeah, we're going to get somebody. And I got to keep this like this in case you didn't take the notes. Take the yellow, and we're going to fill this out. All right, so do be careful on this. All right, who do we got here? Press the calculator on. Nice, you got student number 25, 26. Do you remember that? Wait a minute. Are you 25? Hold on. 26. Yeah, because there's 27. Remember you got called 5 times at one time? Yep. All right, here we go. Okay, a hard-boiled egg. Let's get the easy one out of the way. What's T sub 0? We'll start putting that in there. The initial temperature, which is what?
96.
96. So 96 goes right here. Where do we place the egg to start cooling it down? That's T sub M. So this is 16. How many minutes does it take for the thing to happen in the yellow? 4 goes over here. What happens in 4 minutes? What is T of 4? After 4 minutes, what is the temperature? 45 goes over here. This is T sub 4. And this is why the yellow sentence is enough, because I insert all those things and the only missing fumble thing is the K value. Now this is where I go crazy. Because at this point, that should not be a problem. T sub 0 is easy. Hopefully you understand what T sub M is. Oh, and by the way, on the test Friday, you're getting a little slip of paper with the formulas. Back in the day, we made them memorize the formula. All right, and then we thought, all right, let's just give it a little extra here and let's just usage of formulas, but really what's important. I think I kind of agree with that. It's okay. With people that actually work in forensics, they probably have a tool. But to know where the tool is getting this stuff from is actually the smart stuff, knowing that there's a formula behind it. But so this shouldn't be a problem. I got the formula in front of me. You just got to know what T sub 0 is, T sub M, and then know that this is the new temperature after that time. But now this is where I can't accept errors. I can't anymore. You've got to be good mathematically. All right, so who did I call on here? I had 25. So you got the numbers in. So I'll let you go. 18. Oh, no. Who is 18? 67. Good. You again. What do I do first? It's a PEMDAS question. So what's P? Parentheses. So the very first thing I do is should be 96 minus 16, which is 80. And it is a PEMDAS. You bums that are doing these same mistakes over and over again, that's crushing you in CAT. How do I proceed on next? Do I add Lindsay 16 and 80? Yes or no? No. This is what I'm getting people to do. You're doing this stuff. And do I get rid of 80 first and divide by 80? I just graded a Math 2. I'm grading a Math 2 test right now, and I got people dividing by 80 before they deal with the 16. You got to stop. All right, so I kind of gave it up there. You don't add before you handle this multiply, which I can't really anyway, because I can't take 80 times e to the 4x, because that's an exponent. So what am I going to do with the 16, Lindsay, ultimately? So this is what I'm not getting with some of us. We're not getting these basic skills of solving down. And actually, I'm lamenting about my math tours as well in honors, and they can't balance an equation correctly and get the appropriate steps first. All right, what's the next thing? Nope, I can't really do anything because that exponent's unknown. So I got to do something with that 80. Divide by 80. Because you're free to do it, and you do it after you subtract. All right, I'm going to leave this as 29/80ths. And then, Lindsay, here's the hint, what you do next. Now we got it down to a worksheet question. The worksheet that we did on Friday. What do I change it to? Good. You're telling me that you know it's log base E. Log base E of who? Fumble. Is it a fumble? Put your ID on. How dare you? Slip it out of your pocket. It's illegal. All right. Next equals what? You're one of those, huh? Not putting the ID on. He's ignoring me. Number 25. He already went today. All right. And then I can go to my calculator. Okay, so log base E is ln. Let me clear. Let me get a fresh start. Okay, some of my stuff from the previous stuff is on there. And by the way, I'm going to confer with the other CAT teachers. By the way, I'm going to press enter. And then wasn't it divided by -4, right? Yes. And then now I divide by -4 because it'd be tragic if you didn't close that parenthesis up there. That's bad. If you didn't close that ln, then you would definitely have a wrong answer there. Okay? All right, so that's how I always go about doing it. All right, I'm in the way here. Okay, all right, and I have that up here. Okay, so that worked right there, and I did close the parentheses and did a one shot there. But if you don't close that parenthesis, you're doomed. All right, you wouldn't get that. Now that's a rate. Remember I told you the negative's built in? This is why you get a positive number, because the negative's already in there. So the rate is actually dropping by 25% per minute, okay? And that's what we should kind of understand about that. So this truly is a negative. It's just already built into the formula, which I feel that's kind of weird that they do that, but you don't really have to. If they didn't, then you just get a negative 0.25 right there. So I think it's kind of strange that they do that. Now it's time for the blue. I'm going to go ahead and start inserting stuff here, though. Yeah, I guess how do I explain this then? How did I do it in the other hours? I guess I'm just going to kind of do it and not bother a student on this next part. Okay, now, how long does it take to get to 20 degrees? Well, you could ask yourself, are you asking from 45 to 20 or back to the original 96 to 20? And I guess I'd be okay with either, because you'll get, this took 4 minutes. So if you went from 45 to 20, this answer would be 4 minutes off of if I went from 96 to 20. Does that make sense, anyone? Okay. But I'm going to go from 96. I'm going to go back from the original. So now my new temperature that I'm looking for is how long does it take to get to 20 degrees? You are still surrounded by 16 degrees Celsius. You still started at 96 because I'm going back from all the way back to the original. But now you have this negative 0.2536 ... and it's T that I'm going to find now. So I insert the rates that I found from the previous information given to find my new time in the new situation. And I did not round because you should not round because it's on my calculator. And actually, when I do all my math, my calculator is going to be ready to use this. You really don't want to round on logarithm type questions like this. And then yet again, to just not bother anyone, PEMDAS. Subtract again. No, you don't divide by 80. Oh, I lost my E. Hopefully that's I did that fifth hour too. I lost my E in there. Don't lose your E. All right, sorry about that. Times E raised to. Really look at that formula sheet. Don't lose your stuff. I get people doing that all the time. But next thing, I lament at those that don't subtract 16 first. You can't divide by 80. Then it'd be 16 divided by 80. That's what people do when they divide both sides by 80 first. They ignore that, and then that's why your answer is wrong. And then I think then I divide by 80. This is 4 over 80. And I couldn't care less that reduces. I only mark you wrong if you write a final answer that's not reduced. We're not done. So just leave it. Save your brain power for other things. Not really important. Because now what we're going to do is log, change it to a log, and then it's almost the same exact inputs. Pen is doing its thing again. And then I'd have to divide by that. And then that's why I haven't even touched my calculator yet. So I got that number waiting for me to use, unrounded, which is good for accuracy. All right, and I hope this really all does make sense because it really isn't that bad. All right, I move this. Where am I at? What the heck was going on there? Let's see, where's the top? Oh, there it is. It's confusing myself. It's because I'm in the way here. ln 4 divided by 80. Press enter. And then it was ln 4 divided by 80, right? Okay, for some reason I didn't recognize that answer. Divided by, and everyone oh, by the way, I have to insert the negative because then I'm going to move up here and grab that decimal. If you don't have that ability, just type it as you see it up there. Like if you have a TI-83, then you can type negative and then 0.253, so you can just copy that all in there. Now that's an unrounded all the way out as far as we possibly could get. And we get 11.8. 11.8 what, everybody? Minutes is correct because law of cooling is in terms of minutes. T equals 11.8 minutes. That's from start, the very start, 96 degrees to 20 degrees at the end. Okay? So it's not a hard formula. You got to know where the things go, and then you just got to use PEMDAS in order to get it down to what we had on Friday, which just change an exponent to a logarithm, and it's solvable. All right? That's exactly what happens. Okay, so that's it for 3.5. Here's where we got 3.6, and I do like doing this. That bridges into tomorrow more solving. Okay, this is the money. And then on Wednesday, I'm excited about Wednesday, where I think we'll teach you how to be a millionaire. All right, and actually how to save money through mortgages. How many people have a savings account? Raise your hand. Wow, that's awesome. Actually, my daughter does too. And I do think she gets. How many people get statements? You know, you get statements and you see them. Aren't they like monthly or quarterly? Well, this is what's happening. Not this. This is compounded annually. So I do want to describe this so you have a knowledge of why these are different. And I'm doing one example with these three formulas to show you the difference of calculating. Put $100 in an account, and I make, let's say 8%. By the way,